Alright, let's go through this problem carefully, using the concept of inequalities. A rectangular box is completely filled with dice. Each die has a volume of 1 cubic centimeter. The length of the box is 3 centimeters greater than its width, and its height is 5 centimeters. Suppose the box holds at most 140 dice. What are the possible dimensions of the box? Let's solve this problem step by applying the concept of quadratic inequalities. We know that each die takes up 1 cubic centimeter of space, and the box can hold at most 140 dice. This means the volume of the box can't be more than 140 cubic centimeters. We'll use this information to set up an inequality and then solve it. Step 1. Define the dimensions. Let's begin by assigning variables to the dimensions of the box. Let the width of the box be denoted as W. We know that the length of the box is 3 centimeters more than the width, so we can express the length as W plus 3. The height of the box is already given to be 5 centimeters. And the volume of the box holds at most 140 dice. Step 2. Set up the inequality. The volume of the box is found by multiplying the width, length, and height together. Then, substitute the values of the length, width, height, and volume into the formula. The length is W plus 3 and the width is W, the height is 5 and the volume is at most 140. Step 3. Simplify the inequality. Let's simplify this inequality step by step. 5 times W is 5W squared. And 5 times W times 3 is 15W is at most 140. Then, divide both sides of the inequality by 5 to make the equation simpler. 5W squared divided by 5 is W squared. 15W divided by 5 is positive 3W. Then copy is at most. Then, 140 divided by 5 is 28. Step 4. Express the quadratic inequality as a quadratic equation in the standard form and then solve. So we have W squared plus 3W is equal to 28. Next, we need to write the quadratic equation in standard form. By subtracting 28 from both sides, we get W squared plus 3W minus 28 is equal to 0. To solve this, we'll use the method of factoring. To find the factors, determine the factors of negative 28 whose sum is positive 3. These factors are 7 and negative 4. So, the factors are W plus 7 and W minus 4. Equals 0. By applying the zero product property, we get W plus 7 equals 0 and the W minus 4 equals 0. For the first equation, W plus 7 equals 0, subtract 7 from both sides to get W equals negative 7. For the second equation, W minus 4 equals 0, add 4 to both sides to get W equals 4. Step 5. Find the other dimensions. Since the width of the box cannot be negative, we discard the negative solution. This leaves us with the width equal to 4 centimeters. The length of the box is 3 centimeters greater than the width, so we substitute the value of the width, which is 4, to find the length. Therefore, 4 plus 3 equals 7. Step 6. Check the solution. The length is 7 centimeters, the width is 4 centimeters, the height is 5 centimeters, and the volume is at most 140 cubic centimeters. Substituting the values of the length, width, and height, we calculate 7 times 4 times 5, which is at most 140. The volume of the box is exactly 140 cubic centimeters, which means the box can hold exactly 140 dice, satisfying the condition in the problem. Therefore, the possible dimensions of the box are 7 centimeters by 4 centimeters by 5 centimeters.